Hey there, welcome, or welcome back if you've been here before. I'm Werner, and this here is the whirligig du jour, my late 1940s Brown & Sharp #2 surface grinder. I'm getting this out of storage where it's been sitting since earlier this year when I bought it, because I now have the need to regrind the surface on a couple of Kurt vices that I am restoring for my friend Rodolfo. We're going to start this series by examining this machine more closely. You'll see I broke it and I had to actually braze it back together. And I will also demonstrate what makes it so cool. This machine is fully automated. It's not only hand operated. And it's just such a cool thing. I mean, this machine first went into production, I think, in either the late 1800s or early 1900s and ran through the 50s, I think. And it's just so cool that this could be done with analog controls instead of hydraulics or electronics. It's what I like in a machine, something that I can understand and work on. All right, let's get to it. I want you all to remember that I'm just another yokel who is not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts. This machine is, in my opinion, one of the ultimate whirligigs because it is fully automated mechanically. The only electricity coming into the machine turns the motor. We'll go on the back and look at this. The motor is down here on the bottom, and it turns the pulley, and then the belt comes up to here, and at this level it takes off power for the table to move back and forth, and then up here is where it sends power to the grinder wheel. No hydraulics to move the table, no electronics to move the table, completely automated via mechanical pulleys and gears, and you'll see it. I'll demonstrate it for you and you'll be amazed. It's pretty awesome. So let's zoom in a little bit more. I've got to do a couple of things here to get it going again. One is I need to put an extension cord plug back on it. Now, I have run it before, but I took the plug off to use it for something else. And then the second thing is I need to fill up all the oil ports. So this machine does not have any kind of automatic oiler system. It's all done via oil ports or oil cups. So for fun, let's just count them. Okay, we've got 1, 2, 3, 4 here under this oil. This comes back, and there are 3 more back there, so that's 7, 8, 9, 10, 11, 12, 13, 14. I'll pull this forward. 15, 16, 17, 18, although this one is missing. Number 19 is in there. And here's number 20. And we're not done. "21, 22, 23, 24, 25. So in all, 25 oil cups. So I'm going to go ahead and add oil to all of those and start putting a plug on. The next thing we're going to get after is installing a plug on the machine. So got a twist lock here, 4-prong twist lock, and I've got this 4 by 12 gauge wire that's coming out of the machine. So like I said, I'm gonna try something a little bit different this time. I've seen it done before, but I just haven't done it myself this way. So let's see what happens. I'm not gonna lie, that was not easy. But hey, it worked. So we're gonna run with that one. All right, let's keep moving. Now, I mentioned earlier that this was a 3-phase machine. It's actually a 3-phase 550 volt machine. That's a lot of voltage. Thankfully, this machine came with this transformer here. And it does, it says 480 volts. It works, and it had been in use like this for quite a while. So I'm sure it's going to work for me as well, because it already has. When I put electricity to the grinder the first time, the 2 of the wires were crossed, which is not a big problem. It just caused the motor to run in the opposite direction that it needs to be for the grinder. However, I didn't notice, and so when it spun up, I engaged the table, and the table went moving in the opposite direction and broke this piece of metal off. So this is supposed to sit here like this, and it engages with the dogs that are on the side of the table, and this is the reverse switch. So the dogs hit this tip here and get knocked over, and then the table goes in the other direction, and then when the table gets to the end of travel in the other direction, it hits it and it flips back over. Anyway, mistakes were made, so I need to pull this piece out because I'd like to go ahead and try to try to figure out a good way to connect these pieces back together. So I can get it out this far. Then I'm going to have to do something with this pin here. So I grabbed a roll punch, a roll pin punch, excuse me. See if I can just move it. Well, I just saw it move for a second, but now it looks like it's mushrooming. Let's try this other side and see what happens. Okay, it's moving. That's not bad. If I'm lucky, maybe I can even pull this pin out with a pair of pliers. Oh my gosh, I don't get lucky very often. I tend to get unlucky. Okay, now let's see what happens here. Okay, this is sliding on here. Not sure, this might be where swearing starts. They were not quite there yet. Okay, oh. Alright, it just takes a little patience and wiggling. There we go. Alright, that's free. So I bet if I pulled this other key out and set it aside, this will all come out. And it did. Okay, so now I have this piece that I need to work on. Now that I've got it on my desktop, you can see what it's supposed to look like when it's together. And I still need to take this piece apart here so that I can work on rejoining those two pieces. I ended up having to disassemble half of the broken piece. I removed some of the parts to make sure that I had enough room to get the welding done. It turned out that wasn't necessary. I took some film when I put everything back together, which I'll show a little bit later. Secondly, I'm going to rejoin those parts with silicon bronze. Most likely, since the rest of that machine is cast iron, the broken part is also made of cast iron. I didn't do a spark test because there's not enough metal, but silicon bronze is good for rejoining cast iron pieces, and I'll be brazing, not welding. Brazing is brazing is like soldering, but at a higher temperature, 800 plus degrees Fahrenheit, whereas welding is where you actually melt the original cast iron or the original base metal in the part that you're repairing. So again, brazing, you're only melting the filler rod into the pores around the fracture. All right, the moment has arrived. I have a fresh tip on my TIG welder, tungsten tip. Right in here is the crack. I have it fixtured up on some magnets on my small portable welding table. And I'm going to use some pulse DC welding to put this together with the silicon bronze filler metal. First, before I actually do the welding, I need to heat this up to around 600 degrees in order to help the weld stick better. And I'm going to be doing that with my oxyacetylene torch with my normal cutting head. I don't have a rosebud, and I'm not going to buy one just to do this one project. Okay, see how it goes. A little bit more. Good. I'm seeing red. Check it again. 580, 590. I'm just going to tack it right now. Pulled a little bit apart on the bottom. I think we're gonna have to live with it though. Not fantastic, actually kind of ugly, but that's me. Yeah, it's pretty ugly, but I'll grind it down and make it look prettier. This is a hard way to weld, such a small radius, but I think it's going to work. Alright, we got this looking a little bit better. Still, like here, there's some cavities. They're not really cavities, it's just where I didn't sand or file the metal down all the way to the actual underlying metal. But looks pretty good. I'm happy with it. With the repairs finished, it's time to reassemble this piece. So we're going to start with this. And let's see what we need to do. We need to put some grease on this. This is where the spring goes. And we'll put the spring on. And then we'll put this in here. Okay. Let's see, next move is to install the large pin. So let's see if I can get it started. All right, that's looking good. And let's see, we need to get this out and turned so that we can then install the cap on top, or the knob. So there's the knob. There's a little, let's see if it picks it up. Well, there's a little hole here, and there's also a little hole here, and there's another pin that connects these all together. So hopefully we can get it on there and keep it straight. Yeah, it doesn't want to do that. I'm going to press it in. got things lined up now. See how this goes. All right, not bad. And now that we have that squared away, we'll put this pin in. Try the hammer. Actually, I got another idea. All right, let's try another punch for the move it the final part way. There we go. Mission complete. I finished up with the brazing, and then I used a round file to make things look better, because those are some ugly welds. Yeah, I'm happy with it now. We'll see how it goes. I hope I didn't file off too much of the silicon bronze metal. It seems pretty strong, but the proof will be when I mount it and use it. You know, with that too, I just want to mention a couple things about that welding. A couple of things occurred to me. One, I probably should have let the piece cool at a slower pace. For example, I could have wrapped it in a heat blanket, or I could have put it in some sand after I welded, brazed the piece. I think if it cools too quickly, it might crack at some point in the future. Also, it might have been a good idea for me to put a bevel around the edges of the parts before I soldered them, brazed them together. I was more focused on the fact that the break was very precise, let's say, and the two pieces made it up so well that I did not want to have it misaligned, so I left the edge of the break intact so that it would line up as nicely as possible. But anyways, you know, we'll figure all of this out when I mount it up. If it breaks, then I'll try to do a better job the second time. All right, let's keep on moving. Let's get this machine back together. At least the reverse selector. So we'll pull this rod back out. The key is already in place here. And we will slide this piece on, this selector with the plunger. Okay, make sure everything lines up. Okay, first step. Then we need to just get this pin in here. Well, let's make sure when we pull this back, okay, we have enough room to put this second piece in, and we do. So now we need to drive the roll pin in. And that conveniently lined up quite well. All right. And step 3. We're gonna load this into the hole here. Oh, here. Alright, that looks pretty good. Just need to tighten down a couple nuts. So we'll give this a turn here. And this a final turn over here. That one's actually already tight. Okay, so we're back in action again. Interestingly, I found another 2 oil points while doing this, so remember we have 25. There's one here for because there's a plain bearing inside of here, or a bushing. And there's another one, this must be another one here, these 2 holes. And I'm not sure what that goes down to yet, but I'm going to assume it's another one since there is this one here. And actually there's even a third one right here that had some gunk in it. And that's also going down to the same plain bearing. Alright, I think we're in the home stretch now. So I'm going to put some oil on the ways. Oddly, I don't see any way to oil the ways from the top. Actually, maybe that's a good thing, so junk doesn't fall down. And now I'm going to manhandle the table onto the lathe. Only weighs over 100 pounds. Okay. Okay, there we go. Well, thankfully I can say that it's running and it's working. And I'm going to give a little demonstration here. It's already hooked up to my rotary phase converter. So I've got 3-phase 220 running through a transformer up to 550 volts for this machine. Actually up to 480, but the machine calls for 550. I guess that's close enough. I've got the piece here that I repaired, and let's start it. So notice I don't have a grinding wheel on it, but I don't need one to show you what's going on here. So in order to start the machine moving, just do that. And it's currently moving at 19 surface feet per minute. I can also move at 31 feet per minute, but I'm going slow for now, just because slower seems safer. I'm going to shut it off and go right here. And then if I want it to automatically move backwards or forwards, I have some settings here. And I can have it so that each step is somewhere between 1/100th and 1/10th of an inch. And it actually has settings for both the moving when the table is at the left end and the right end. So if for some reason you wanted to do, let's say you wanted to do 2 swipes on the same lane, you would set one of these to 0 and one of these to 1/10. It would go across once, go back at the same place, and then hop forward 1/10 of an inch, and then do it again. So anyways, to turn that on, I just come down here and put that in gear and start it. There's the clicking. It's currently moving backwards. I'll zoom in so that you can see see a good place where you can tell that it's actually moving. So I'm going to wrap up the video here. I still have a lot of work to do on this machine. The table needs to be taken care of. I'm going to clean the machine up too. I've got to get the magnetic chuck on here. I've got to mount a grinding wheel and just make sure everything is functioning well before I could even start grinding away the vices, which is why I decided to get this thing out of storage and start working on it. So as always, I appreciate you coming by to check out my videos. Thank you, and I'll see you on the next one. So long for now. This is where I go, oh shit, you dumbass, you put it on backwards.
Ouch! What the?